Atmospheric chemistry. What do you mean by atmosphere? Earth atmosphere. This refers to the mixture of gases surrounding Earth, primarily composed of nitrogen, about 78%, and oxygen, about 21%, with a small amount of other gases like carbon dioxide, water vapor, and argon. The Earth atmosphere is divided into several layers, including the troposphere, where weather occurs, stratosphere, which contains the ozone layer, mesosphere, thermosphere, and exosphere. The atmosphere plays a crucial role in maintaining life on Earth by regulating temperature, protecting from harmful solar radiation, and enabling weather patterns. Write down the composition of the atmosphere. The composition of air is primarily made up of the following gases: nitrogen, 78.08%, the most abundant gas, inert and stable, vital for nitrogen cycle; oxygen, 20.95%, essential for respiration in living organisms and combustion process; argon, 0.93%, a noble gas that is chemically inert; carbon dioxide, 0.04%, 400 ppm, increasing, important for photosynthesis and acts as a greenhouse gas; water vapor, 0 to 4%, varies by region and weather. Its concentration depends on humidity levels and plays a key role in the water cycle and climate. Other trace gases: neon, 0.0018%, helium, 0.0005%, methane, 0.00018%, krypton, 0.0001%, hydrogen, 0.00005%. These gases together make up of air we breathe near Earth's surface. Nitrogen, 78.084%, oxygen, 20.946%, argon, 0.934%, carbon dioxide, 0.037%, neon, 0.0018%, helium, 0.00052%, methane, 0.0001 15%, krypton, 0.00011%, 0.00011%. Write down the importance of atmosphere. The atmosphere plays a crucial role in maintaining life on Earth by regulating temperature, protecting from harmful solar radiation, and enabling weather patterns. Here are the key importance of the atmosphere: support life. The atmosphere provide essential gases like oxygen for respiration and carbon dioxide for photosynthesis, supporting plant and animal life. Regulates temperature. It acts as a blanket, trapping heat through the greenhouse gases. Greenhouse effect. Trapping heat through the greenhouse effect. This keep the earth warm enough to support life by maintaining a stable temperature range. Protects from harmful radiation. The ozone layer in the stratosphere absorbs harmful ultraviolet radiation from the sun, protecting living organisms from DNA damage and health issues like skin cancer. Facilitates water cycle. The atmosphere plays a key role in the water cycle, enabling process like evaporation, condensation, and precipitation, while are essential for maintaining water supplies. Briefly describe the layers of atmosphere with any diagram. The Earth atmosphere is divided into five main layers, each with distinct characteristics. Here's a brief description of each: exosphere, more than 100 kilometer; troposphere, 690 kilometer; mesosphere, 85 kilometer; stratosphere 50 kilometer, troposphere 20 kilometer এই আছে আর কি troposphere 1 to 2 12 kilometer, 12 to 15 kilometer, 15 to 85 kilometer, 85 to 600 kilometer, and 600 kilometer and more. Troposphere altitude 0 to 12 kilometer feature. This is the lowest layer where weather occurs, and where most of the atmosphere's mass is concentrated. Temperature decreases with altitude. Stratosphere altitude 12 to 50 kilometer, 31 miles feature contains the ozone layer, which absorbed UV radiation. Temperature increases with altitude due to ozone absorption of sunlight. Mesosphere altitude 50 to 85 kilometer, 53 miles features. In this layer, most meteoroids burn up. Temperature decreases with altitude, making it the coldest layer. Thermosphere altitude 85 to 600 kilometer, 373 miles feature a very thin layer where the average occur and space shuttle orbit. Temperature increases with altitude due to solar radiation. Exosphere altitude 600 kilometer to 1000 kilometer, 10,000 kilometer, 6,200 miles feature the outermost layer where atmospheric particle gradually escape into space. There is no clear boundary between the exosphere and outer space. Please briefly discuss the causes of variation among atmospheric layer with respect to temperature, moisture, and chemical composition with height. The atmosphere varies significantly across its layer in terms of temperature, moisture, and chemical composition due to several factors. Here's a briefly discussion. Temperature variation. Troposphere temperature decreases with height. This is because the Earth's surface absorbs solar energy and warm the air near the ground. Stratosphere temperature increase with height due to the absorption of ultraviolet radiation by the ozone layer, which heats this region. Mesosphere temperature decreases with altitude. Again, as there is less ozone and fewer molecules to absorb solar energy. Thermosphere temperature increases significantly with height due to the absorption of high energy solar radiation, X-ray, UV. Even though the air is very thin, moisture variation. Troposphere this layer contains most of the atmosphere's moisture, and it decreases with altitude. Weather and clouds form here because of the high moisture content stratosphere and above. Moisture level are extremely low, making these layers dry. Water vapor contains out in the troposphere, and very little reaches higher layers. Chemical composition. Troposphere mostly composed of nitrogen and oxygen with trace gases. Water vapor, carbon dioxide. This layer also contains pollutants, aerosols, and moisture. Stratosphere contains a higher concentration of ozones. In the ozone layer, oxygen is more important here for absorbing UV radiation, and the chemical composition becomes more stable. Mesosphere and thermosphere. The air becomes extremely thin. The mesosphere contains fewer molecules, and in the thermosphere, light gases like oxygen and nitrogen are still present but less dense. Above, hydrogen and helium dominate in the exosphere. Ozone layer. Explain. The ozone layer is a part of the earth atmosphere that absorbed most of the sun's harmful ultraviolet radiation. It protects living organisms from UV damage. Human activities, especially the use of certain chemicals have damaged it. But international agreements like the Montreal Protocol are helping it recover. Montreal Protocol are helping it recover. Write down the ozone formation process and its impact on stratosphere. The formation of ozone in the stratosphere primarily occurs through a series of reactions involving ultraviolet light. This is known as the ozone oxygen cycle. Uh, O2 photodissociation, when high energy ultraviolet UVC radiation strikes an oxygen molecules. It splits into two individual oxygen atoms. O2 plus UVC is equal to 2O. Ozone formation: the free oxygen atoms then collide with another oxygen molecule, forming ozone. O plus O2 is equal to O3. Ozone breakdown: ozone molecules absorbed lower energy UV radiation, mainly UVB, which breaks the ozone back into an oxygen molecules and a free oxygen atom. This free oxygen atom can then recombine with another O2 molecule to form ozone again, maintaining a continuous cycle. Impact on the stratosphere: UV radiation absorption. Ozone in the stratosphere absorbed harmful ultraviolet UVB and UVC radiation, preventing most of it from reaching Earth's surface. This protect living organisms from DNA damage, skin cancer, and other health issues. Temperature increases: the absorption of UV radiation by ozone hits the stratosphere, causing the temperature to rise with altitude. This creates a temperature inversion that stabilizes the stratosphere and helps to separate it from the turbulent weather field troposphere below. Why ozone layer is important? The ozone layer is important because it blocks harmful UV radiation. It absorbed and filters out of majority of the sun's ultraviolet rays, which can cause skin cancer, cataract, and other health issues in humans, as well as harm animals and plants. Protect ecosystem: it helps maintain the balance of ecosystems by shielding marine life, plant and animal from UV damage. Preserves climate stability by filtering UV radiation. It plays a role in regulating the earth climate and temperature patterns. Without the ozone layer, life on earth would face increased risk from harmful UV radiation. Describe the composition and characteristics of troposphere that affect the atmospheric chemistry. The troposphere is the lowest layer of Earth atmosphere, extending from the surface up to about 8 to 15 kilometer, 5 to 9 miles. Its composition and characteristics greatly influence atmospheric chemistry, weather patterns, and human activities. Composition: gases: nitrogen 78%, oxygen 21%, argon 0.93%, carbon dioxide 0.04%. Water vapor variable 0 to 4% by volume. Trace gases: methane, ozone, and another minor components. Key factors affecting atmospheric chemistry include mixing and temperature. Vertical mixing distributes gases and pollutants, affecting chemical reactions. Water vapor derives cloud formation and reactions like the creation of hydroxyl radicals that break down pollutants. Photochemical reactions, sunlight derives reactions that produce ozone and impact air quality. Greenhouse gases, carbon dioxide and methane contribute to the greenhouse effect and climate change. Which hemisphere of Earth receives more energy from sun in July? Why? In July, the northern hemisphere receive more energy from the sun due to the tilt of earth exists during this time. The northern hemisphere is tilted toward the sun, leading to longer days and more direct sunlight. This results in higher solar radiation and warmer temperature. In contrast, the southeast hemisphere is tilted away from the sun, experiencing shorter days and less direct sunlight, which means it receives less solar energy during this period. This seasonal variation is a key factor in the difference in climate between the hemisphere throughout the year. The Köppen climate classification is a system for categorizing the world's climate based on temperature, precipitation, and vegetation types. Developed by climatologist Vladimir Köppen, it divides climates into five main groups, each with subcategories: tropical, warm temperatures year round with significant rainfall. Significant rainfall subtypes include tropical rainforest, tropical monsoon, and tropical savanna. Dry, characterized by low precipitation, includes desert and semi-arid regions. Subtype are arid and semi-arid. Moderate temperatures with distinct seasons. Subtypes include Mediterranean, CHA, humid subtropical, CFA, and ocean, CFB, and CFC. Continental, more extreme temperature variations between seasons, typically in areas with forest. Subtypes include humid continental, DFA, DFB, and subarctic, DFC, DFD. Polar, very cold temperature year round, includes tundra and ice cap climates. Subtypes are tundra and ice caps. Solar radiation and the global energy budget. Okay. Explain the solar radiation budget of Earth and atmosphere. The solar radiation budget of the Earth and atmosphere refers to the balance between the incoming energy from the sun and the outgoing energy from the Earth. This balance determines the planet overall climate and temperature. Here's how it works. Incoming solar radiation insulation. The sun emits energy in the form of solar radiation, primarily visible light, ultraviolet, UV light, and infrared radiation. About 100% of the energy from the sun reaches the earth and its atmosphere. Distribution of solar energy. Of the incoming solar energy absorbed by earth's surface, 51%, about 51% of the incoming solar radiation is absorbed by The Earth's surface heating it, absorbed by the atmosphere gases like water vapor, ozone, and carbon dioxide, along with clouds absorbed about 19% of the solar radiation, reflected back to space. Roughly 30% of the incoming solar radiation is reflected back to space by clouds, atmospheric particles, and the Earth's surface. This is known as the albedo effect, where brighter surfaces like snow, ice, and clouds reflect more sunlight. Outgoing energy, Earth emissions. To maintain a balance, the Earth must emit an equivalent amount of energy back to space. This happens in two forms: thermal infrared radiation. After absorbing solar energy, the Earth's surface heats up and emits energy in the form of infrared radiation, latent and sensible heat. Energy is also transferred back to the atmosphere through process like evaporation. When water evaporates, it carries latent heat into the atmosphere. Convection, warm air rises and transfers sensible heat upward. Greenhouse effect. Some of the outgoing infrared radiation is trapped trapped by greenhouse gases, example carbon dioxide, methane, and water vapor in the atmosphere. This natural greenhouse effect keeps the earth warm enough to support life by slowing the escape of heat into space. Without it, the planet would be much colder. Energy balance. For the earth climate to remain stable, the incoming solar energy must equal the outgoing energy. If more energy is trapped, as with increasing greenhouse gases, it leads to global warming. If more energy escape, it leads to cooling. Describe about the factor affecting incoming solar radiation. Several factors affect the amount of incoming solar radiation. Insolation that reaches the Earth's surface, latitude, equator versus poles. Solar radiation is more direct and concentrated at the equator, leading to higher energy input. Toward as you move toward the poles, the sunlight strike the earth at a lower angle, spreading over a larger area, which reduces the intensity of the radiation. Time and day. Sun's position. Insolation is highest when the sun is directly overhead at noon, the lowest in the morning and evening when the sun is near the horizon. Station. Earth tilt. The tilt of Earth axis, 23.5 degree, affect the angle at which solar radiation hits the Earth throughout the year, causing seasonal variations in insolation. During summer, the hemisphere tilted towards the sun receives more direct radiation, while the opposite hemisphere gets less in winter. Altitude of the sun. Higher altitudes, the atmosphere is thinner, so less solar radiation is scattered or absorbed, allowing more to reach the surface. Atmospheric condition. Clouds reflects and absorbed incoming solar radiation, reducing the amount that reaches the earth's surface. Aerosol and dust. Particles in the atmosphere, such as dust, smoke, and volcanic ash, can scatter and absorb sunlight, lowering the intensity of solar radiation reaching the surface. Distance of sun. Earth orbit. The Earth orbit is slightly elliptical, meaning the distance from the Sun changes throughout the year. During perihelion, Closest to the sun, the Earth receives slightly more solar radiation than at aphelion, farthest from the sun. Surface albedo, reflectivity of the surface. Surfaces with high albedo, such as snow, ice, and desert, reflect more solar radiation, reducing the amount absorbed by the Earth. Darker surface like forest and ocean absorbed more sunlight. Solar activity, sunspot and solar flares, sunspots and solar flares. Variations in solar activity such as sunspots and solar flares can affect the amount of radiation emitted by the sun, though these changes are typically small over short period. Briefly describe the factor affecting variation of temperature on Earth's surface. Several factors causes variations in temperature on Earth's surface. Latitude. Areas near the equator receives more direct sunlight, making them warmer, while regions near the poles get less direct sunlight, resulting in cooler temperature. Altitude. Higher altitude have thinner air which hold less heat, causing temperature to decrease as elevation increases. Proximity to water. Proximity to water. Coastal areas have more moderate temperatures due to the heat absorbing and releasing properties of water, while inland areas experience more temperature extremes. Ocean currents. Warm or cold ocean currents can influence coastal temperature, warming or cooling nearby land areas. Cloud cover. Clouds block sunlight during the day, keeping temperatures cooler, and trap heat at night, keeping temperatures warmer. Seasons. Seasons. The tilt of the earth causes seasonal temperature changes, with more sunlight in summer and less in winter. Winds. Winds can transfer heat from warm areas to cooler regions, affecting local temperatures. Principle of electromagnetic radiation. The principle of electromagnetic radiation refers to the fundamental properties and behavior of energy that is propagated through space as electric and magnetic field. Here are the key principles. Wave particle duality. Electromagnetic radiation exhibit both wave-like and particle-like properties. It travel in wave but also behave like particles called photon, especially when interacting with matter. Speed of light. Electromagnetic radiation travel at the speed of light in a vacuum, which is approximately 3 lakh kilometers per second or 1 lakh 86,000 miles per second. Wavelength and frequency. Wavelength, the distance between successive peaks of the electromagnetic wave frequency. The number of wave cycles that passes a point in the second measured in Hertz. There is an inverse relationship between wavelength and frequency. Higher frequency waves have shorter wavelength, and lower frequency wave have longer wavelength. Energy of photons. The energy of an electromagnetic wave is directly proportional to its frequency. Higher frequency radiation like X-rays or gamma rays carries more energy, while lower frequency radiation like radio waves carries less. Electromagnetic radiation spans a wide range of wavelength and frequencies, forming the electromagnetic spectrum. This spectrum include from longest to shortest wavelength, radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma rays propagation. Electromagnetic waves can travel through the vacuum, the space, or through a medium, and they always propagate as perpendicular oscillating electric and magnetic field interaction with matter. Electromagnetic radiation interact with matter in various ways. Reflection, bouncing off surfaces, refraction, bending as it passes through different media. Absorption, energy is absorbed by the material, increasing its temperature. Transmission, passing through a material without being absorbed. Scattering, deflection in many directions, air pressure and winds. Describe the global wind belts. The global wind belts are large scale wind pattern that circulate across the earth. These wind belts influence global weather patterns and climate. They are divided into three main regions in the hemisphere. Trade winds, 0 to 30 degree latitude, 0 to 30 degree latitude, located between the equator and 30 degree latitude in the both hemisphere. Direction, winds blow from the east northwest in the northern hemisphere and southwest in the southern hemisphere. Causes warm air near the equator rises and moves toward the poles. As it cools, it sinks it around 30 degree latitude, creating a pressure difference that derives the winds back toward the equator roll. These winds were historically important for trade routes and still influence tropical weather system. Westerlies, 30 to 60 degree latitude, found between 30 to 60 degree latitude in both hemisphere. Direction, winds blow from the west to the east, cause air is as the air moves from the subtropical high pressure areas at 30 degree toward the poles. It is deflected east to west toward the Coriolis effect. Role Yes, westerlies influence weather patterns in mid latitudes, especially in regions like North America and Europe, and contribute to the movement of weather systems. Polar westerlies 60 to 90 degree latitude occur between a 60 degree latitude and the poles. Direction, winds blow from the east to the west, cause cold air sinks at the poles and flows toward lower latitudes where it meets the warmer air of the western ice roll. Polar eastern ice contribute to polar climates and influence the movements of cold air masses towards latitude. Wind classification refers to categorizing winds based on their speed, duration, and geographic occurrence. Here's an overview of the key types of wind classification based on speed. Light bridge 1 to 5 mph, gentle and barely felt. Moderate wind 6 to 20 mph, can saw trees or flags. Strong winds 20 to 30 mph, 32 to 48 kilometer per hour, can move low subject. Galley 39 to 54 mph causes structural damage storm. 55 to 72 mph very destructive winds hurricanes. Force winds above 73 mph hurricane force. Above 73 mph highly destructive associated with storms or cyclones based on geographic occurrence. Local winds, land and sea ridge. Coastal wind causes by temperature differences between land and sea, mountain and valley bridges. Air movement in mountainous areas due to temperature differences between valleys and peaks. Katabatic winds, cold winds that flow downhill from elevated areas, common in polar regions. Global winds, trade winds found between 0 degree and 30-degree latitude, blowing east to west. Westerlies between 30 to 60-degree latitude, blowing west to east. Polar easterlies between 60-degree latitude and the poles, blowing east to west. How is the climate of Bangladesh influenced by monsoonal winds? The climate of Bangladesh is significantly influenced by monsoonal winds, primarily of South Asian monsoon. South Asian monsoon, here's how it impacts the climate. Seasonal rainfall, wet monsoon. Wet monsoon, June to September. June to September. The southeast monsoon brings heavy rains, accounting for about 7 to 70 to 80% of the annual rainfall. This is crucial for agriculture, especially rice cultivation. Dry season, October to May. The retreat of the monsoon leads to a drier climate with lower precipitation levels. Temperature regulation, cooling effect. The onset of the monsoon usually results in the lower temperatures and higher humidity, providing relief from the heat of the pre-monsoon season. April to May, high humidity. The monsoon also increases humidity levels, contributing to a tropical climate with warmer night. Agricultural cycle. The monsoon season is vital for crop growth, particularly rice, which is the staple food. Farmers rely on the monsoon rains for irrigation. Flooding risk. Heavy monsoon rains often lead to flooding, especially in low lying areas and river basins. While flooding can be detrimental, it also replenishes soil fertility. Cyclones. The monsoon season can bring tropical cyclones which pose risk of severe weather, flooding and damage in infrastructure and livelihoods. What is atmospheric pressure? Atmospheric pressure is the force exerted by the weight of air molecules above a given point on the Earth's surface. It is typically measured in units like pascals, millibars, or inches of mercury. Inches of mercury is key points. Weight of air. Weight of air. Atmospheric pressure results from the gravitational pull on air molecules as altitudes increase. There is less air above, leading to lower pressure. Measurements. Standard atmospheric pressure at sea level is about 1,1325 pascal. Variability. Atmospheric pressure can vary due to factors like weather systems, temperature, and humidity. High pressure systems generally brings clear skies, while low pressure systems can lead to clouds and precipitation. Effects on weather. Changes in atmospheric pressure are associated with weather patterns and phenomena influencing wind direction and speed. Impact on life. Atmospheric pressure affects various biological processes and can influence activities like breathing and the behavior of fluids. Describe the causes of variations of atmospheric pressure. A variation in atmospheric pressure is caused by several factors. Altitude, atmospheric pressure decreases with increasing altitude. Decreases with increasing altitude. As we go higher, there are fewer air molecules above you, leading to lower pressure. Temperature, warm air is less dense and rises, resulting in lower pressure in that area. Conversely, cold air is denser and sinks, creating higher pressure. This temperature variation can lead to changes in pressure system. Humidity, moist air high humidity is less dense than dry air because water vapor is lighter than nitrogen and oxygen. Areas with high humidity can experience lower pressure. Weather system, low pressure systems, cyclones are associated with rising air, which can lead to cloud formation and precipitation. High pressure systems, anticyclones, are linked to descending air, resulting in cleared, drier condition. Geographical feature, topographic topography can influence local pressure variations. Mountains can block airflow, creating areas of low pressure on the leeward side, while valleys can trap cooler air. Seasonal variation can affect temperature and humidity, leading to changes in pressure patterns. For instance, warmer temperature in summer can create low pressure areas, while colder winter temperature can lead to high pressure. Briefly describe the global pressure belts. Global pressure belts are zones of high and low atmospheric pressure that influence weather patterns and climate. They are primarily caused by the uneven heating of the Earth's surface. Here's brief overview. Equatorial low pressure (ITCZ), location near the equator, 0 degree latitude. Characteristics characterized by low pressure due to rising warm moist air. This zone is associated with heavy rainfall and thunderstorms. Subtropical high pressure location, approximately 30 degree latitude, both hemisphere. Characteristics characteristics areas of high pressure caused by descending air. These regions often have clear skies and dry conditions, leading to desert climate. Sahara, Sunaran, mid latitude low pressure, between location between 30 degree to 60 degree latitude, both hemisphere. Characteristics are characterized by areas of low pressure associated with the meeting of warm and cool air masses. This region experience variable weather, including storms and precipitation. Polar high pressure location near the poles around 90 degree latitude. Characteristics areas of high pressure due to cold, dense air sinking. These regions are cold and dry, often with little precipitation. Pressure gradient force. The pressure gradient force is a fundamental concept in meteorology and physics that describe how difference in atmospheric pressure derive when. Here's a brief overview definition. The pressure gradient force is the force that results from changes in atmospheric pressure over a distance. It acts from areas of higher pressure to areas of lower pressure. Key points: direction. Winds is generated when the pressure gradient force causes air to move horizontally from high pressure areas to low pressure areas. Strength. The strength of the pressure gradient force is proportional to the pressure differences and inversely proportional to the distance over which that difference occurs. A steeper pressure gradients, a large pressure difference over a small distance, resulting in stronger winds. Isobursts. Lines called isobar connects points of equal atmospheric pressure. Closely spaced isobars indicate a steep pressure gradients and are associated with stronger winds. Stronger winds while widely spaced isobars indicate a gentle gradient and higher winds. Balance with other forces. The pressure gradient force is one of the key force that, along with the Coriolis effect and friction, helps determine wind speed and direction. Planetary winds. Planetary winds are large-scale wind patterns that circulate around the Earth, driven by the uneven heating of the planet, and the rotation of the Earth. They play a crucial role in regulating climate and weather. Here's a brief overview. Trade winds. Location between the equator and 30-degree latitude in both hemisphere. Direction blow from east to west, northwest in the northern hemisphere, and southwest in the southern hemisphere. Characteristics: these winds are steady and consistent, brings moisture and warm temperature, often leading to tropical weather patterns. Westerlies location between a 30 to 60-degree latitude in both hemisphere. Direction blow from west to east. Characteristics: the westerlies are responsible for the movement of weather systems in mid latitudes and are often associated with storms and variable weather condition. Polar easterlies. Polar easterlies location polar from a 60-degree latitude to the poles. Direction blow from east to west. Characterized these cold winds are influenced by the polar high pressure systems and contribute to the generally cold and dry condition in a polar radiation. Intertropical convergence zone location near the equator. Characteristics: not a wind belt but a region where the trade winds from both hemisphere converge. This area is characterized by low pressure and significant rainfall, leading to tropical thunderstorms, factor affecting winds. Wind is influenced by several key factors. Pressure gradient force. This force arises from a difference in atmospheric pressure. Air moves from high pressure areas to low pressure areas, creating winds. Creating winds. A greater the pressure difference, the stronger the winds. Coriolis force due to Earth rotation. Moving air is deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This effect influence wind direction and helps shape weather patterns. Centrifugal force in a rotating system like cyclones. Centrifugal force acts outward from the central of rotation in affects wind direction and speed, particularly in curved path. Frictional force near the Earth's surface. Friction slows down wind speed and alters its direction. This force is stronger in areas with rough terrain, such as the forest and mountains, compared to open water or flat land. Atmospheric moisture budget. Briefly describe the atmospheric components of global hydrological. The hydrological cycle, water cycle, is the continuous movement of water within the earth and atmosphere. It involves several key processes that circulate water between a different reservoirs, ocean rivers, atmosphere, and land. The main steps of the hydrological cycle include evaporation. Water from ocean, lakes, and other bodies of water is heated by the sun and turns into water vapor, rising into the atmosphere. Rising into the atmosphere, transpiration. Plants release water vapor into the atmosphere through tiny pores, in their leaves, contributing to overall atmospheric moisture condensation. Water vapor cools as it rises in the atmosphere, forming clouds through the process of condensation, precipitation. When water droplets in a cloud becomes too heavy, they fall back to earth as the precipitation. Rain, snow, sleet, or hail. Runoff precipitation that lands on the ground flows over the surface into rivers, lakes, and oceans, or infiltrates the soil to discharge groundwater infiltration and percolation. Water seeps into the ground and can move through soil and rock layers to become groundwater, which eventually returns to surface water bodies. Groundwater flow. Water stored in underground aquifers can flow slowly and discharge into rivers, lakes, and oceans, maintaining the cycle. How many types of cloud are found in the sky? Describe any two of them. Clouds look different depending on what they are made of. Clouds forming from water droplets tend to have well-defined edge, whereas clouds forming from ice crystals tends to have fuzzy, less distinct edge, and look white. The shape and depth of clouds depends on the temperature, humidity, and the degree of uplifting. Clouds are classified into three basic forms on the basis of their appearance shape: cirrus, cumulus, stratus. Cirrus, wispy, feather-like thin clouds formed from ice crystals at high altitudes, usually near the tropopause at 10 to 12 km. Cumulus, puffy, cotton ball or cauliflower shaped clouds develop vertically from a flat bottom. Stratus, relatively thin and blunt, like layered, limited developed shape clouds. Air parcel rising, lifting process or mechanism. Several conditions that cause air to rise are known as lifting mechanism. These are convective lifting, convergence lifting, orographic lifting, frontal lifting. Orographic lifting: air is forced to rise as it moves over mountains or hills. As the air rises, it cools, condenses, and forms cloud, often causing precipitation on the windward side of mountain, while the leeward side remains dry. Rain shadow effect, convection lifting: when the ground heats up from sunlight, the air above it warms and rises. As this warm air ascends, it cools, potentially forming cloud and causing thunderstorms if it reaches the dew points. Frontal lifting: when cold air mass meets a warm air mass, the warmer, lighter air is forced upward. This can cause clouds and storms. Particularly in the case of a cloud, a cold front, warm front lift air more gradually, leading to a steady precipitation. Convergence lifting occur when air masses from different directions meet and are forced and are forced upward. This is common in low pressure areas. Such as the intertropical convergence zones, where it results in cloud formation and heavy rain. Global water budget balance. The global water budget balance refers to the equilibrium between the amount of water entering and leaving the earth system. It ensures that the total amount of water on our planet remains constant over time. This balance is maintained through a complex cycles of evaporation, evaporation, condensation, precipitation, and runoff. Key components of global water budget balance. Evaporation, water from oceans, lakes, rivers, and even soil evaporates into the atmosphere primarily due to the sun's heat. Condensation, as the evaporated water cools in the atmosphere, it condenses into droplet or ice crystals, forming clouds. Precipitation, when the water droplets or ice crystals in a cloud becomes they fall back to the earth's surface as rain, snow, sleet, or hail. Runoff, precipitation that falls on land can either be absorbed by the soil or flow over the surface as runoff, eventually making it way back to ocean, lakes, or reverse infiltration. Some of the precipitation that falls on land is absorbed by the soil or become a groundwater, where condensation forms in the atmosphere. It occurs when water vapor cools and changes in a state from a gas to a liquid or solid. This can happen in several ways. Cooling near surface, when warm moist air comes into contract with a cooler cooler surface like ground, buildings, and vegetation. The air near the surface cools. As it cools, its ability to hold water vapor decreases, causing the excess moisture to condense in droplet or ice crystals. Adiabatic cooling, the air rises in the atmosphere. It expands and cools due to decreased atmospheric pressure. This cooling can cause the water vapor in the air to condense, forming clouds. Orographic lifting, when air masses are forced to rise over mountains or other elevated features. They cool adiabatically, leading to condensation and formation of precipitation. Precipitation refers to all liquids, rain and frozen snow or sleet, forms of water shedded from the cloud. The formation of all forms of precipitation from cloud depends on temperature. There are two processes to form a precipitation: collision and coalescence. Process in warm cloud. Tiny droplet in cloud collide and stick together to create large drops that are too big to be held in cloud. Start to fall and incorporate more droplet on me down. Thus, different size of raindrops reach at our surface. The size of a raindrop depends on length of way down and availability of moisture. Typical raindrops have a diameter of 2 mm and fall at a velocity of about 20 km/h. Any drops larger than 5 mm tends to break into smaller ones due to wall resistance. If rain falls through colder air near the ground, it freezes. It freezes to become sheet. Bargeron process in cold cloud. Precipitation develops by Bergeron process involves the growth of ice crystals in a cloud at the expense of water droplets. A cloud may contain a mixture of very cold water droplets and teeny ice crystals and teeny ice crystals. The water droplets evaporate faster than the ice crystals because water molecules are less tightly bound in water droplets than in ice crystals. This situation favors moisture to the condense onto the pre-existing ice crystals to form hexagonal snow flakes. Yeah, if the air below the cloud is very cold, the snow falls as powder like flakes. If the air is close to the melting point temperature, large wet clumps of snowflakes fall down. If the air is warmer than 0 degrees Celsius, the snow transforms into rain before hitting the ground. Describe the two types of clouds. Cirrus clouds altitude found in high altitude above 20,000 feet. Above 20,000 feet, appearance thin wispy feather like a cloud made of mostly of ice crystals. They often appear white and are spread out in the sky. Weather indicator generally associated with fair weather, but can indicate that a changes in weather such as a warm front or a storms is approaching. A formation of formed when water vapor condense into ice crystals at high altitude where temperatures are very cold. Cumulus clouds found at low to middle altitudes, usually below 6,600 feet. Appearance puffy white clouds with flat bases, often resembling cotton balls. They usually have a well-defined structure. Weather indicate typically associated with fair weather, though they can grow into larger clouds. Cumulonimbus that produce thunderstorms formation formed by rising warm air convecting lifting that cools and condense at lower altitudes. Major water reservoirs on Earth face changes in water. A phase in the transformation of a substance from one phase to another, solid to liquid melting, liquid to solid freezing, liquid to gas vaporization, evaporation, gas to liquid condensation, solid to gas sublimation, gas to solid sublimation deposition. Latent heat refers to the amount of heat energy required to change in state of a substance without changing its temperature. For example, during the phase change from a solid to liquid melting or liquid to gas evaporation, heat is absorbed or released, but the temperature remains constant. Sensible heat is the amount of heat energy that causes a changes in the temperature of a substance without changing its phase. This heat can be sensed or measured with a thermometer as it results in a temperature increases or decreases. Humidity is the amount of water vapor present in the air. It plays a key role in weather, climate, and human comfort. Types of humidity: absolute humidity, the actual mass of water vapor in a given volume of air; relative humidity, the ratio of the current amounts of water vapor in the air to the maximum amount of air can hold at a given temperature expressed as a percentage. Specific humidity, the mass of water vapor per unit mass of air. Critical temperature is the biggest temperature at which a substance can exist as a liquid, regardless of the pressure applied above this temperature. A substance cannot be liquefied no matter how much pressure is increased, and it exists only as a gas or supercritical fluid. Zero dew point. The dew point is the temperature at which air becomes saturated with water vapor, causing it to condense into liquid water. Dew, yeah, when the air cools to the dew point, the relative humidity reaches 100% and condensation begins to form on surfaces like grass or windows.